Hello guys, so I'll be continuing with the organic chemistry. If you are between grade 10 to 12, ensure that you follow my TikTok account because there'll be a lot of program during the year to ensure that I help you get that distinction that you deserve. Again, if you want us to request for you that we apply for your universities, colleges and bursaries, go and click the link on my bio and request today to ensure that we take care of all your applications. Otherwise, let's actually start to answer this question. So I just want you to see how I'll be answering this question, and technically that's how you should actually do it on your exam room. So let's actually start. So what you do is you do have questions aside, but before you actually attend the questions, you should actually try to analyze this table that you are actually being given. Right now, let's look at A. What is A? So we know that A it's actually an alkane, right? How do we know that it's an alkane? We realize this because of the functional group that this structure actually have. And then let's try to give the IUPAC name of this structure. Well, we are going to count to look at the longest chain, right? Because we are having the methyl branches, right? So let's actually count. If we count the longest chain, we're going to have 1, 2, 3, 4, 5, 6. Let's count to this point. We're going to have 1, 2, 3, 4, 5. This is not the longest chain. If we count 1, 2, 3, 4, 5, 6, this is also the longest chain. But to make matters easy for us, let's just count like straightwards, right? So I'm going to write numbers from 1, 2, 3, 4, 5, 6 from left to right. Let me also write from right to left. I'm going to have 1, 2, 3, 4, 5, and 6, right? So I want to write the IUPAC name of this organic compound. And how do I do it? Because I have the branches, I also need to label on which position on my longest chain are the methyl branches attached to. So I need to have the combination of small numbers within the branching. So for example, this carbon has a branch and I'm having 5 and 2. And also this carbon has a branch and I'm having 3 and 4, right? So obviously the 5 and 2 one has the smaller number, which is 2. So it means that I am going to count that this branch, it means that I am going to count from left to right. That is the order I'm going to take because it consists of a smaller number 2 on the first branch. Where else when I come from right to left, the smaller number that I'm going to have is 3, right? And 3 is much larger from 2, so I need 2 to be the smaller number. So when I draw this, I'm going to say, okay, on which carbon is this branch attached to? This one, it's actually at 2, but there's another one attached where, if this is number 2, it means that this one is actually attached at carbon number 3. So I need to say number 3. Because there are 2 branches of methyl, I need to say di. If there were 3 branching, I should say tri. But because it's 2, it's di. And then these are the methyl. Dimethyl. Why is this a methyl? Well, because let me try to look for a video I was doing, if there's still those notes here. I want to show you why is that one a methyl. Yeah, I think I'm not seeing it. Yeah. I've probably thrown out the papers. Okay. So the reason why this is a methyl is because remember carbon number 1. If an organic compound has 1 carbon, it's a meth. So these ones are actually methyls because it is just 1 carbon that is actually branching. We're having a branch on carbon number 2, and we're also having a branch on carbon number 3. So there are 2, it's di, and they are the methyl. And then 6, it means it's hexane. So that is the IUPAC name of A, right? And then we do that, and now we go to B. So for B, we don't know what the hell that is. So what we're going to do is we're going to draw 3 carbons. So I'm going to say 1, 2, 3. and we're having 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. Well, I don't know where this O is going to be, but I know that the structure is something like this, because I don't know whether the OH is going to be here on the first. I don't know if it's going to be on the first carbon, or maybe it's going to be on the second carbon. So I don't know where it's going to be. I'm just going to mark it that, okay, I have a problem, this is unfinished. Perhaps on the questions there might be more information about it. And then let me move to C. What is C? So C, it is the it is an ester, right? So C is actually an ester. So how do you actually name or you give the IUPAC name of an ester? Well, the IUPAC name of an ester, you need to know that this one that is branched with a carbon, it is actually an alcohol. So it's going to be, okay, so this one is actually an alcohol, and then this one that is bonded to this one in this manner, it is actually your carboxylic acid. So I want you to comment on my comment section. Tell me, what is the IUPAC name of this structure? What do you think this IUPAC name is actually going to be? If you don't understand it, I'm going to make a complete different video trying to explain how to label this. It's what most of the people think it's difficult, but it's not. But I can tell you something. The end term is wait. If you don't understand it, forget about it. Okay, write this and write it on your comment section. Okay, let's actually look at D. What's actually happening with D? Well, we do know that this is a ketone because of this one, right? So if we draw the structural formula of this, because it's a pent, it means it's 5. 1, 2, 3, 4, 5. So we know that the functional group is going to be on carbon number 2. Remember, even if I write it here, it's fine. Even if someone write it here, it's also fine, right? It is fine. Everything's gonna be okay. Okay, let's actually look at E. So E, it is 4-methyl pent-2-ine. So this ine tells us that this is an alkyne. So, and this alkyne is a pent, and pent means 5. This is D, by the way. So 1, 2, 3, 4, 5. And this ine is actually on carbon number 2. So this is actually carbon number 2. 1, 2. Right? 1, 2. It is actually on carbon number 2. And we're having a methyl on carbon number 4. So it's 1, 2, 3, 4. So on carbon number 4, we're having a methyl. So it's 1, 2, 3, 4. So on carbon number 4, we're having a methyl. That's easy as that. And then I'm going to draw this. 1, 2, 3. I think there should be another 4 in here. And that's how you draw this. This is E. So after doing this into your exam, you then, okay, let me just remove this, go into the questions. The questions say, for compound D, write down the homologous series to which it belongs to. We've already said that compound D is a ketone, right? We've already said this. We saw this is a ketone. IUPAC name of a functional isomer. What is the IUPAC name of the functional isomer of compound D? Let's look at it. This is compound D, right? So the functional isomer of compound D, it is always an aldehyde, right? So it means that you are just going to take this O and put it put it here, or maybe put it here. So it's just going to change into an aldehyde. So what is the IUPAC name of that aldehyde? So it's going to look like this: 1, 2, 3, 4, 5. So it is just going to say 1, 2, 3, 4, 5, and then just put that O here or whatever, wherever you want to go. And this is actually going to be what? Pentanal, right? This is just going to be pentanal. So it's just going to be an aldehyde. Let's actually look at this. Write down the IUPAC name for compound A, right? So what is the IUPAC name for compound A? You realize that we have already done it, right? It is 2.3 dimethylhexane. And then the other question says structural formula of compound E. So you also realize that we have already done the structural formula of compound E. Here it is. So every time you come across this sort of question, before you run into the question, you need to first analyze everything that is actually written. Oh my God, written, written on the on your diagram, and then you try to figure out what's actually going on, and then you are going to start answering your question. Otherwise, guys, enjoy the rest of your day.